Using similar right triangles for slope. Triangles ABC and DEF are similar right triangles. Use proportions to show that the slope of AC is equal to the slope of DF. This problem has so much academic vocabulary. We are talking about similar right triangles, we're talking about proportions, and we're talking about slope. So what I want you to write at the top of your paper is the slope formula. It's m equals y2 minus y1 over x2 minus x1. And we're going to see how that matches the picture that we have over here for number 1 pretty soon. By the way, do you have to remember this formula? No, you don't, because you are an 8th grader and this formula is on your referenced materials. So you do not have to memorize this one. It's going to be on your formula chart. So let's take a close look at our task here. We need to find the slope of AC and we need to find the slope of DF. So let me highlight those. You know what? I'm actually going to use different colors to highlight them. There we go. So here's AC and here's DF. There we go. It's like a part of AC. So it would be a whole lot easier to find the slope of these lines if I wrote down the coordinates of these points. Let's write them down. Point A is at -1, 6. Point D is at 1, 2. Point F is at 3, -2. And point C is at 5, -6. Be sure that you're labeling this on your paper too. You want to have those 4 points labeled so that they're easy for you to use, as we're about to use them with the slope formula. Let me zoom out a little bit so that you can see the slope formula. All right, I find it a lot easier if I label my points x1, y1, and x2, y2. I'm going to do the slope of AC first. So let me label x1, y1, and then x2, y2. Awesome. Now I'm just going to substitute this into the formula. So I need y2 minus y1. That's -6 minus 6. Okay, that's my numerator. And then for my denominator, I need 5 minus -1, right? x2 minus x1. So 5 minus -1. There we go. It looks kind of funny, minus minus 1. If you prefer to write it like that, you could. That's fine. All right, so let's do the math. Let's subtract here. -6 minus 6 is -12. And 5 minus -1, that's really going to be like 5 plus 1. So that's going to be 6. All right, so -12 over 6, that's a slope of -2 over 1, or we could just call it -2, right? Those would be the same thing. Did I have to manually calculate all this? No, I could have typed it into Desmos. That would have been fine. So what I want you to do is I want you to pause the video and repeat that for the next point. Let's label them together, and then I want you to substitute them. So here's x1, y1, and here's x2, y2. So I want you to substitute those values into the formula and tell me what the slope of DF is. Pause the video, hit play when you're ready to talk about the slope of DF because you have already attempted to calculate it. So let's calculate the slope of DF. All right, y2 minus y1 is going to be -2 for y2, minus 2 for y1. And then x2 minus x1 is just going to be 3 minus 1. Great. -2 minus 2 is -4. And 3 minus 1 is 2. So this gives me -2 over 1. Think, pair, share. First you need to think. I want you to think about what do you notice about the slopes of DF and AC. Then you're going to share what you think with a partner. And then the teacher is going to ask you to share your thoughts with the class. So set a 30-second timer and let's think, pair, share. Excellent job noticing that both of these line segments have a slope of -2. I'm going to clear off some of my work here. You keep yours. I just need some more space. I have a question for you. I wonder if I chose another point on this line, would the slope be the same or would it be different? Let me show you what I mean. Like, what if I chose this point right here? I'm going to label that G, and I guess the coordinates for that would be 0, 4. What do y'all think? Would the line from A to G, let's see, that would be right here, is this going to have a slope of -2? And then what about the line segment from G to C? Would that also have a slope of -2, or would it have something different? Talk with your partner. I'm curious what you think. Would the slope be different, or would it be the same if I calculate it using point G instead of the other points that I just used? Let's calculate it. So first I'm going to find the slope of AG. So I've labeled my points x1, y1, and x2, y2. And you might be wondering right now, does it matter which one I decide is point 2 and which one I decide is point 1? No, it doesn't matter, as long as you are consistent. If you make one of the x's x2, then the y that goes with that point must be y2. So you have to be consistent. Okay, so I have labeled mine, and I'm going to go ahead and substitute into the equation the slope formula. So my y's are just going to be 6 minus 4. Let me show you what I just did there. I just did 6 minus 4. That's y2 minus y1. And in my denominator, I'm going to have -1 minus 0. 6 minus 4 is 2, and -1 minus 0 is -1. So look at that. That is a slope of -2. All right, let's try GC. So for GC, let me label point C down there. See, that's going to be 5, -6. And I'm going to leave G as x1, y1. So now I'm going to label C x2, y2. I erased the other point so that we didn't have too much to think about here. All right, so for my numerator, I'm going to subtract my y's. That's -6 minus 4. And here they are. Those are those two values I'm subtracting. And then for my denominator, I have 5 minus 0. Great. Okay, so that's going to be -10 over 5, and that comes out to -2. All right, so my slope is -2. What that seems to suggest is that any point that I choose on the hypotenuse of those similar triangles, like any point that's on that line, I'm going to have the same slope between those 2 points, right? At least that's what the experiment that we just did seems to be showing. So let's take that knowledge and use it to take a look at problem number 2. The line on the coordinate grid includes the hypotenuse of right triangle EFG. Right triangle RST is similar to right triangle EFG. Vertex R is at -2, 8. The slopes of the hypotenuses of the two triangles are equal. Which ordered pairs could be the coordinates of vertex V? Select all that apply. Okay, being honest, I'm tired after reading that. There was so much academic vocabulary in there. Let's take a look at it. Okay, the line on the coordinate grid includes the hypotenuse of the right triangle. Right triangle RST is similar to right triangle EFG. We have vertex R, we have the slopes, the hypotenuses, and then the two triangles are equal. Which ordered pairs? Okay, so there is a lot of academic vocabulary going on here. One word, I know that you're familiar with right triangle. So a right angle, you remember, is a 90-degree angle. A right triangle is just a triangle that has a right angle. And then we are talking about the hypotenuse of the right triangle. You're going to learn more about this in the spring, but for now, just know that the hypotenuse is the longest side of that right triangle, and it's always going to be opposite the right angle. So that vocabulary word is showing up here. Don't let it scare you. It's just talking about the longest side of the triangle. Okay, we've got that covered. We know that similar shapes have proportional corresponding sides. And let's just go ahead and start drawing what this might look like here. We see that vertex R is at -2, 8. I'm going to plot that. Here it is. This is vertex R. Let's label it. We don't know the other vertices of triangle RST, but we know it's similar to this one, right? So for example, a similar triangle might look like this. There we go. And the way I could tell that's similar is it has corresponding proportional sides. Let's look, 1, 2, this has a height of 4 and a base of 2, and my new triangle has a height of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, okay, and a base of 1, 2, 3, 4, 5. Okay, so then I could write a ratio, 10 over 5 is equal to 4 over 2. That's what it means to be proportional, right? So one point that could be vertex T would be this point right there. Because if I drew that point, it would create a triangle that is similar to the one I started with. And you know what? I'm actually going to change these ratios I wrote. I'm going to make this a -10 and then make that a -4. The reason I'm doing that is because if I make those negative, then I can use these ratios to calculate the slope of my hypotenuse of this line right here, right? The slope of that line, well, let's see, from point R, it goes down 10 and it goes 5 to the right. That is a slope of -2. And my little triangle, EFG, well, it goes down 4 and it goes 2 to the right. And that is a slope of -2. So we know that the slopes of similar right triangles, the slopes of the hypotenuses are the same, right? That's what we discovered earlier. I have too much on here, so I'm going to clear it off a little bit. But let me keep this other point, because this point could be vertex T, right? This is a possibility for vertex T. I wonder if you can think of some other points that maybe could be vertex T. Look at the list on the left and talk with your partner. Which of those 2 points do you think would work and why? So from this list, the 2 points that would work are 0, 4, there it is, and 6, -8. Let me show you where those are. Here they are. And the thing that's special about these 2 points, the thing that makes them work, is that they are both on the yellow line that I highlighted, right? They are both on the hypotenuse of triangle EFG if we were to extend that hypotenuse further. That's why they work. And let's just see what those similar triangles might look like. So the first triangle would be like that. And that one is similar. In fact, it's congruent to EFG. The next triangle would look like this. It's much bigger. And it is also similar. And all of these, if we were to calculate the slope between those 2 points, no matter where we calculate it, it's going to be a slope of -2. So for this problem, we're going to check off 0, 4, and we're going to check off 6, -8. If this was a choice, we would also check it off, but it's not. And what I want you to know, when you see a problem like this, what you're really doing is you're saying, well, which points are on the line? Because if they're on the line, then I know they could be part of the hypotenuse of a similar right triangle. I know that they would give me a slope that's equal to the slope of the line that's already been given.